Hi, we're on section 1.3, changes in matter. Today we're going to talk about what is a physical change, what is a chemical change, and how are changes in matter related to changes in energy. All right. You look up from the sand sculpture you and your friends have been working on all afternoon. Storm clouds are gathering, and you know the sand castle may not last long. You pull on a sweatshirt to cover the start of a sunburn and begin to pack up. The gathering of the storm clouds, the creation of the sand art, and your sunburn are examples of changes in matter. Chemistry is mostly about changes in matter. In this section, you will read about some of those changes. Physical change. In what ways can matter change? A physical change is any change that alters the form or appearance of matter. So, a physical change is any change that alters the form or appearance of matter. but does but does not make sorry but does not make any substance in the matter into a different substance. So it does not change substance, okay? It is not a different substance. For example, a sand artist may change a formless pile of sand into a work of art. However, the sculpture is still made of sand. A substance that undergoes a physical change is still the same substance after the change. Changes of state. As you know, matter occurs in three familiar states: solid, liquid, and gas. We also talked about plasma. We're not going to worry about that right now. Okay, suppose you leave a small puddle of liquid water on the kitchen floor. When you come back 2 hours later, the puddle is gone. Has the liquid water disappeared? No. A physical change happened. The liquid water changed into water vapor, a gas, and mixed with the air. A change in state such as from a solid to a liquid or from a liquid to a gas is an example of physical change. Okay? So here's an example of change of state. At room temperature, the element iodine is a purple solid that easily becomes a gas. Okay? So that's a change of state. Changes in shape or form. Is there a physical change when you dissolve a teaspoon of sugar in water? To be sure, you need to know whether or not the sugar has been changed to a different substance. For example, you know that a sugar solution tastes sweet, just like the undissolved sugar. If you pour the sugar solution into a pan and let the water dry out, the sugar will remain as a crust on the bottom of the pan. The crust may not look exactly like the sugar before you dissolved it, but it is still sugar. So dissolving is a physical change. Other examples of physical changes are bending, crushing, breaking, chopping, and anything else that changes only the shape or form of matter. The methods of separating mixtures, filtration, and distillation that you read about in section 1 also involve physical changes. Okay? Why is the melting of an ice cube called a physical change? Because it only changes the form of it. It doesn't change the substance. It is still water. Okay? So if we crush an aluminum can doesn't change aluminum into another metal. It's still aluminum. When table sugar dissolves in a glass of water, it is still sugar. So these are examples of physical change. Chemical change. A second kind of change occurs when a substance is transformed into a different substance. A change in matter that produces one or more new substances is called a chemical change. So it produces one or more new substance. That's a chemical change or a chemical reaction. In some chemical changes, a single substance simply changes to one or more other substances. For example, when hydrogen peroxide is poured on a cut on your skin, it breaks down into water and oxygen gas. In other chemical changes, two or more substances combine to form different substances. For example, iron metal combines with oxygen from the air to form a substance, iron oxide, which you call rust. Unlike a physical change, a chemical chain produces a new substance with properties different from the original substance. So it is a new substance with properties different from the original substance. Here are some examples of chemical change. One familiar chemical change is the burning of natural gas on a gas stove. Natural gas is mostly the compound methane, CH4. When it burns, methane combines with oxygen in the air and forms new substances. These new substances include carbon dioxide gas, CO2, and water vapor, H2O, which mixes with the air and are carried away. Both of these new substances can be identified by their properties, which are different from those of methane. The chemical change that occurs when fuels such as natural gas, wood, candle wax, and gasoline burn in the air is called combustion. Other processes that result in chemical change include electrolysis, which we talked about a lot in the last chapter with Mr. Davy, oxidation, tarnishing. The table in figure 17 describes each of these types of chemical change. Okay, combustion. Rapid combination of a fuel with oxygen produces heat, light, and a new substance. So examples are gas, oil, or coal burning in a furnace. Electrolysis, using electricity to break up compounds into elements or simpler compounds. So breaking down water into hydrogen and oxygen. Oxidation, slowly combination of a substance with oxygen, such as rusting of an iron fence. Tarnishing, slow combination of a bright metal with sulfur or other substance, producing a dark coating on the metal. So this is like the tarnish of brass. Okay, conservation of mass. A candle may seem to go away when it is burnt, or water may seem to disappear when it changes to a gas. However, scientists long ago proved otherwise. In the 1770s, a French chemist, Antoine Lavoisier, carried out experiments in which he made accurate measurements of mass both before and after a chemical change. His data showed that no mass was lost or gained during the change. The fact that matter is not created or destroyed in any chemical or physical change is called the law of conservation of mass. Remember that mass measures the amount of matter. So this law is sometimes called the law of conservation of matter. Suppose you collect all the carbon dioxide and water produced from methane when methane burns, and you measure the mass of all this matter. You would find that it equals the mass of the original methane plus the mass of the oxygen that was used in the burning. No mass is lost because during a chemical change, atoms are not lost or gained, only rearranged. A model for this reaction is shown in figure 19. So figure 18 here is natural gas or methane is the fuel used in many kitchen ranges when it burns and no mass is lost. Okay, so conservation of matter. The idea of atoms explains the law of conservation of matter. For every molecule of methane that burns, 2 molecules of oxygen are used. The atoms are rearranged in the reaction, but they do not disappear. So you can see our methane molecule has 1 carbon, and it has 1, 2, 3, 4, 5 hydrogens. Okay, then we have 2 oxygen molecules. So remember we talked about the oxygen gas comes in pairs. So we have 2 here and 2 atoms of oxygen gas. Okay, so if you will notice, carbon dioxide. Okay, so our carbon comes here. Okay, and this is our 1 oxygen and 1 oxygen. Okay, now we have an oxygen. Oops. So this oxygen comes here. This oxygen comes here. Okay, we still have our hydrogens left over. So we have so we have 1 hydrogen here. Here's our other hydrogen. 1 hydrogen comes here, and the other hydrogen comes right here. So we have not lost a single molecule. They've just been rearranged. That's the law of conservation of mass. Okay? Matter and thermal energy. Do you feel as if you are full of energy today? Energy is the ability to do work, or cause change. Every chemical or physical change in matter includes a change in energy. A change as simple as bending a paperclip takes energy. When ice changes to a liquid water, it absorbs energy from the surrounding matter. When a candle wax burns, it gives off energy. Temperature and thermal energy. Think of how it feels when you walk inside an air-conditioned building from the outside on a hot day. Whew! Did you exclaim about the change in temperature? Temperature is the measure of the average energy of random motion of particles of matter. The particles of gas in the warm outside air gives greater average energy than the energy of motion than the particles of air in a cool building. Okay? Flow of thermal energy. Thermal energy flows from a hot cup of cocoa to the warm hands on a day. So it's important to know which way thermal energy flows. Okay. Thermal energy is the total energy of all the particles in an object. Okay, thermal energy is the total energy of all the particles in an object. Most often, you experience thermal energy when you describe matter, such as in the air in the room, as feeling hot or cold. Temperature and thermal energy are not the same, but temperature is related to the amount of thermal energy an object has. Thermal energy always flows from warmer to cooler objects. This is very important. Thermal energy always flows from warmer matter to cooler matter. Okay, so in the example of the hot coffee, the coffee or the cocoa is hotter than your hands. So the energy is going to flow from the hot cocoa to your hands. Okay? Thermal energy and change in matter. When matter changes, the most common form of energy released or absorbed is thermal energy. For example, ice absorbs thermal energy from its surroundings when it melts. That's why you can pack food and drinks in an ice-filled picnic cooler to keep them cold. The melting ice is an endothermic reaction, a change in which energy is taken in. Changes in matter can also occur when energy is given off. So an exothermic releases energy. Exo, it exits. Endo, inside, it takes in energy. That's how you remember the difference. Endothermic, exothermic, okay? Taking in or giving off energy. Combustion is a chemical change that releases the energy in the form of heat and light. When you have fire, you take advantage of this exothermic change if you've warmed your hands near a fire. So when something burns, it gives off the energy or heat. So it leaves, it exits, it's exothermic. Okay? All right. That is the end of our lesson for this section. So here is your homework, and I will see you again next time. Bye.